Okay, students, we'll go for ninth question, okay, which is much similar to question number 8. Obtain a DFA to accept strings of zeros and ones having no three consecutive zeros. See, in previous question, like it must contain three consecutive zeros, then only it was able to accept it. Okay, but here, no three consecutive zeros. If there is more than two consecutive zeros, then it should be rejected over here. Okay, so from the previous problem, okay, I just consider this skeleton, okay, which is actually accepting three consecutive zeros. Okay, but in that only changes is what Q3 was the final state. So three consecutive zeros were able to be accepted. Okay, but here we need to make Q3 as a non-final state. Okay, apart from Q3, rest of all the states, whatever we have, that should be made as a final state. Fine. Like three consecutive zeros, if it is there, then it should be rejected. Okay. When it will be three consecutive zeros, if you are passing Q2, then it will be considered as three consecutive zeros. Is it right? Here, 10100010. If it is there, it should be rejected, right? Because three consecutive zeros we have. Then later, 1001010. What it should be? It should be accepted or rejected. It should be accepted, right? So we'll just compare these two. Okay. So what I need to do, I need to make these three states as final state. Okay, except Q3, the rest of all should be made as final state. Okay, because the only condition is what? If we are having three consecutive zeros, then only it should be rejected. Otherwise, it should be accepted. Okay, so now if we are having only one, condition satisfied or what? Okay, three consecutive zero we don't have. It should be accepted. So see a single one if you have. So self loop for Q naught, it is a final state, it will be accepted. 10, we don't have a three consecutive zero. So 10, Q1 will be the final state. Okay, so this will be accepted. Then 00, if it is available, then see here 100. Q2 is the final state. Okay, so it will be accepted. After Q2, if it is 1, then it will be going back to Q naught. Yes, it is also final state, it will be accepted over there. Okay, then later again like 1010 combination if you are having, that will be also able to be accepted by this particular DFA. Why? See here, okay, if you are in Q2 with input 1, okay, then you are going for Q1, sorry, Q0, okay, then again 0 you are having, Q0 to Q1 you are coming back, later again 1 you are having, okay, you are going for Q0, it is also a final state. After that last input is what? 0, so you are coming back to Q0, Q1, okay, on receiving 0. So it is also a final state, so it will be accepted. But just observe this condition, okay, this condition 1010010. Okay, when we are having this three consecutive zero, then only you are going for the final Q3 state exactly. Once you are entering for Q3 state, means you had encountered continuous three zeros. Then later, whatever we are having, that should be rejected. Okay, so we are providing a self loop for Q3 and we are making Q3 as a non-final state. Okay, we'll observe this input. 101 we have, right? 101. You are in Q0 again. Later, 000 we are having 000. Okay, 000. You are in Q3. Later, 10 you are having 1 inside Q3 itself, 0 inside Q3 itself. So this will be rejected. Okay, if it is accepted for three consecutive zeros, then Q3 should be made as a final state. Okay, but here we are saying like Q3, like the three consecutive zeros should not be available. That's why the Q3 we are making it as non-final state, and rest of all should be made as final state. Okay, so how we solved in the previous problem like that itself, we need to check for for Q0 both the transition 0 and 1, for Q1 also both the transition 0 and 1, like that for each and every like states and for every alphabets also. Yeah, okay, so as usual the transition table, fine, and later the machine m is equal to, everything should be included over here. Okay, how we did for the previous problem, same thing we need to do over here. Okay, so your m will be equal to q, right, comma sigma comma delta comma q naught comma f, right, q naught comma f. Then your q will be equal to q naught comma q1 comma q2 comma q3. Okay, then later sigma will be equal to, as usual, 0 comma 1. Okay, then later q naught is the start, q naught is the start, And the final state will be equal to what? Three final states we have. Be careful. Q0, comma, Q1, comma, Q2. Okay, so three final states. Then later, transition table, if you want to draw, okay, so it will be for 0 and 1 exactly. So Q0, we have, it is what the start and also the final state, both should be specified. Then later Q1, it is also a final state. Then later Q2, it is also a final state. Okay, at last Q3, which is non-final state. Q0 on receiving 0, it will go for Q1. On receiving 1, it will remain in Q0 itself. Q1 on receiving 0, it will go for Q2. On receiving 1, it will go for Q0. Okay. Then Q2 on receiving 0, it will go for Q3. Okay. And if it is receiving 1, it will be going back for Q0. Okay. Then later Q3, both are same. Like Q3 on receiving 0 and 1, it will be remaining in Q3 itself. So this is what the transition table for this particular example. Okay. So this is how, like, no three consecutive zeros problem can be solved. Okay, students. So we'll wait with next problem. Okay, that is question number 10.